Hello, hello, hello. I hope we are live. Yes, we are live. Good evening, bacha log. How are you all? Everyone, please be active in the chat box and let me know. My voice is crystal clear. Is it audible to everyone or not? Almost theory of machine. This big journey has reached its end. Today is the second last lecture, and we are going to talk about a very interesting phenomena of the physics, which is gyroscopic couple. What is gyroscopic couple? Where does it comes into picture? What does it do? We are going to understand all these aspects, and believe me when I'll show you what gyroscopic couple does. So at the end, you will everyone will say, Gareth, this is gyroscopic couple. This thing I have already witnessed in my life. In my childhood days, I have used this gyroscopic couple, but you haven't realized yet. Before I start this technical part of the gyroscopic couple, can you tell me how many of you have played this kind of game in my village? We used to do this kind of activity. Na? We used to have a old cycle ka tire, and we used to play with that cycle tire, and the boy is hitting it, and this tire spins, it goes, it rolls. So the same tire, if I simply try to stand this on the ground, it is not stable. It falls either this side or this side. But what magical happens when someone starts rolling it? So while doing this rolling motion, this tire has achieved, I don't know from where, some kind of stability. It is not now. Now it's not following. Now it's not falling this side or this side. But if it is stationary, if you try to make it stand, it immediately falls. You leave it, immediately it falls either this side or this side. So there is something magical related to this spin which we have provided here. It provides stability to this rolling element. Or you have, many of you might have played with the top. है We call it in Hindi, we call it as lattu. Top. Top is a device where we, attach a rope, and when we throw it, it spins. And the same thing with the top also. If you don't spin it, try to make it stand on the ground, sir, it won't be possible for you to make it clearly standing here. It falls either this side, this side, this side. It falls immediately. It falls. And wherever you have made it stand like this, the moment you release it, if it tilts even by 0.1 degree, so its weight is going to make it fall. Wherever it leans, it falls that side. But if I spin it at very high speed, now it has got somehow some magical stability. So there is something magical related to this spin quality. So what happens when we rotate few things? What happens when we rotate something? What magical is happening? Let's try to decode this. This all is happening because of the gyroscopic couple. How this gyroscopic couple acts, let me try to tell you. And without getting into huge mathematical detail, let's try to feel this concept. Suppose in 3D I'm talking, we are having, this is x-axis beta, this is your y-axis, and this is your z-axis. These are the three mutual perpendicular axes. This is your x-axis, y-axis, and suppose this is your z-axis. Suppose I have some rotor, which rotates about any of these axes. Suppose, for example, x axis ke about it is going to have rotation, and x axis ke about, when I am seeing from this side, I can see that rotor about x axis it spins. It may be clockwise direction mein or anti-clockwise direction mein, and the clear view is from this side. Okay, from right side, I will say that sir, rotor is here. From right side I am looking, so it is clockwise. It is mandatory for you to tell from right side it is clockwise, because the same rotation from right side it is clockwise. If you start seeing this from the left side, it looks like anti-clockwise. So it is very, very necessary for you to tell me clearly that from which side you are actually watching this. So I have a rotor. How does it look? Sir, my rotor looks like this. This is my rotor. It is rotating from left, from right side. I am seeing this is maybe clockwise or anti-clockwise. So I have said, for example, anti-clockwise from right hand side. This is anti-clockwise from right hand side. It can be clockwise also. Acha, whatever, either you write this complete sentence, or simply to avoid any kind of confusion, you can simply show using right hand thumb rule. As a vector quantity, you can show its omega. So this is anti-clockwise. This is my right hand, and right hand, curl your fingers in anti-clockwise direction. So thumb is indicating towards this. So x axis, positive x axis towards this direction, I'll be having your omega vector. Omega vector is where, sir, this is my omega vector. This is my omega vector. And this rotor which is rotating here, suppose this rotor ka moment of inertia something mk square, k is the radius of gyration. So this x axis is called as axis of spin. Axis about which rotor is rotating is called as axis of spin. Axis of spin. Now, if perpendicular to this axis of spin, maybe y axis or maybe z axis, about any of these axes, if my axis of spin, it starts rotation. If, for example, if about y axis, my axis starts rotation like this, y axis ke about it will rotate like this, maybe from the top, maybe clockwise or maybe anti-clockwise. Or if I am saying about z axis, if it rotates, so x axis is rotating about z axis is towards you, so it will be rotating like this. So about any of these perpendicular axis, y axis or z axis, if my axis of spin starts rotation, so that axis about which this axis is spinning, it is called as axis of precession. Axis of precession. How does it look? Sir, from top I am looking, this is my x-axis where rotor is there, and this x-axis about y-axis, it is rotating. Say, for example, from top it is anti-clockwise direction mein or maybe clockwise direction mein. As an example, let me write clockwise. Sir, if it is rotating clockwise, with what velocity? That velocity is called as omega p, precession speed. How does it look? Sir, this is from the top, it is clockwise. Clockwise from top. I am looking at this omega p from the top, and it gives me a feel of clockwise direction. You can also show this using vector quantity. Vector quantity will look like this. From the top you are seeing it is clockwise, so omega p vector if I will show, so that will be in this direction. You don't need to show both these. Either you will show like this clockwise, anti-clockwise, or you will show this vector. Because I'm explaining things, so that's why I'm telling you both. Any one you have to represent. So if my axis of spin of the rotor, this axis starts rotation about any other axis, any other perpendicular axis. So about the third axis you will be having gyroscopic couple, active gyroscopic couple, and opposite to that we will be having reactive gyroscopic couple. So this third axis about which couple is going to act, it is called as axis of gyroscopic couple. This is axis of gyroscopic couple. Z axis is the axis of active gyroscopic couple as well as reactive gyroscopic couple. Now, what is the active couple and reactive couple. What is the meaning of this? This is not action and reaction. And let me explain this thing with a simple concept. In class 10th or 12th, you might have studied about circular motion. So try to understand the analogy. Suppose if something is rotating in a circular path, I have a particle which is moving in a circular path. Careful, this is the circular path, and I have a thread on which I have a stone. I have a stone here. It is rotating. So when this particle is going to have circular motion, we have on this particle, we are having centripetal force which is acting towards the center always. Why? Sir, this particle is at this instant, it is having some v velocity. Some v velocity, say it is moving in this direction. And on this particle, because it is moving on a circular path, so some centripetal force must be there. Without centripetal force, you can't even imagine circular motion. So this particle, why it is capable of moving in the circular path? Because some centripetal force is acting. And what is the centripetal force? Some force which is towards the center. It is not a new force. Any force which acts towards the center will act as a centripetal force. So what is the centripetal force here? Sir, this thread we have, thread ka tension T will be acting as a centripetal force. So I will say centripetal force is in this direction. This is centripetal force. Tension T. Who has provided this? Sir, tension T has provided this centripetal force. And because of this centripetal force, this is my m mass ka body. Force is acting on it in this direction. And because of this force on this m mass body, there will be some acceleration. What is that acceleration? So that acceleration will be in the direction of force. This will be the acceleration. Centripetal acceleration we call it. Force is equal to mass into acceleration. So from this relation, Newton's second law, I can find out this much force is acting. What is the mass? So how much acceleration this body is going to feel, I can find out this. So this acceleration is going to act on this body, and because of this acceleration, which is perpendicular to the velocity, direction of velocity is going to change. What happens? Very next moment, this particle was earlier here. This particle next time when it moves here, its velocity ka direction, it was earlier in the vertical up direction. Now it changes. How much, sir? It becomes this. Although I am not commenting on its magnitude, anything, I am not talking about the magnitude. Sir, at least its direction is going to change. Because of which acceleration? Because of this particular acceleration. So what acceleration which is perpendicular to velocity, it is responsible for changing the direction of the velocity. So velocity direction changes. Why? Because some acceleration was acting. Why acceleration was acting? Because some force was there. And very next moment, when we have reached here, I will say now, because of this tension T, now this tension T is acting here. This is tension T towards the center. This is tension T which is acting as a centripetal force towards the center. So I'll be having some acceleration which further is going to change direction of the velocity. So continuously velocity ka direction is going to change. Why? Because always perpendicular direction where I am having some force which is resulting in some acceleration. Acha, this is centripetal force because of which this circular motion is happening. But how many of you have ever used a playground where you might have used a marigold? Are we back? We are live again. Hello. Yes. Sorry, there was some technical glitch. We are back again. So what I was talking, I was giving you an analogy that whenever we are having a circular motion, a particle which is moving on this circular path, so its velocity is continuously changing. That's what I was saying. Velocity is here. Very next moment, particle moves this side, and its velocity will be somewhere here, this side. Even though magnitude is constant, its direction is changing. That means velocity is changing, and if velocity is changing with time, that means there is some acceleration. What is that acceleration? That acceleration, I have said that acceleration is because of some centripetal force. So we are having this. Oh, don't do this again, please. So we are having this tension T of the thread, which acts as a centripetal force, and this centripetal force will result in some acceleration. And because of this acceleration on mass m ka body, force F is acting, mass m is the mass of the body, and because of this force on m mass body, what is the acceleration? A acceleration, which changes the velocity direction. This is how circular motion is happening. And this centripetal force is the active force. We call this centripetal force as active force. Centripetal force is the active force. Active force means this is the real force which is acting on the body, and because of this only this body is capable of making this circular motion. Now, if you are sitting on this particle, now sit on this particle. If you have ever enjoyed that marigold wala jhula, so whenever you are sitting here and moving around this circular path, what do you feel? You feel some pseudo force, inertia force, which is in this direction. We call this as centrifugal force. We call this as centrifugal force. Let me make this by dotted line. Dotted line is just representing that this is not a real force, this is a pseudo force. Only the person who is sitting here, he can feel this. No one else, only the person who is sitting here can feel this. Tell me. This is called as centrifugal force. Centrifugal force. Centripetal force was acting on it, but the person who was sitting on this, he will feel the effect of centrifugal force. When you are sitting on the marigold, go around that jhula, so you will feel why you are making this circular path wala motion, because some centripetal force is acting, from somewhere it is coming. But you, the person who is sitting on this, you will feel the centrifugal force. You will feel that somebody is trying to throw you out. So this is called as your reactive force. And my dear, effect of the reactive forces are seen on this body. Can I write? Effect of reactive force is seen on the body. Same logic say we are going to have active gyroscopic couple, reactive gyroscopic couple, but the effect of reactive couples are also going to be seen. Now, I think that slide we have missed, so let me just quickly draw once again. We are having x-axis, y-axis, and this is your z-axis. X, y, and this is your z-axis. This I have called axis of spin. I was calling this as axis of precession. This is your axis of precession. And this z-axis, third perpendicular axis, is called as your axis of gyroscopic couple. So gyroscopic couple, active couple, and reactive couple. both are going to act along this z axis. They will be opposite to each other. Gyroscopic couple, like this. We are having this rotor. This is the rotor, and its omega vector I have shown in this direction. This is your omega vector. ठीक है, rotor के बारे में what I have said. This is my rotor, whose moment of inertia, it is mk square, like this. What was the omega p? Omega p ko I have said from the top it was looking like clockwise. So let me write omega p from top, it was clockwise. Top say this is clockwise. Vector के फॉर्म में if I'll show, it will be vector downward direction में. You will be having vector like this. Any one only you have to show. This is your omega p. Precession speed, the speed at which axis of spin is going to have rotation. And omega के लिए what I have said, sir, this is omega. From right side it is anti-clockwise direction में. Anti-clockwise from right hand side. Sir, how much is the gyroscopic couple which is going to act here? Torque is I omega omega p. This is the value. This much torque is going to act, I omega omega p. So examination में sometimes they are asking, tell me how much is the magnitude of gyroscopic couple. Sir, this is the magnitude of gyroscopic couple. I is the moment of inertia, omega is the angular speed at which rotor is doing rotation, spin speed, and omega p is the precession speed, with what speed your axis is rotating. Put all these values in MKS, kg meter square, radian per second, and this torque you are going to get in Newton meter. This is the torque. Now, what is the direction of reactive couple? I am interested in finding out direction of reactive couple, because effect of that reactive couple is going to be seen on this rotor. How do I get the direction? The main important thing is direction, finding out the direction, and then they will, once you are comfortable with finding out the direction, then they can ask questions on aeroplane, ship, car, bike, whatever questions they are asking, you can very easily answer it. How to find the direction? For direction I have a simple rule. How to find the direction? How to find direction? And believe me, examination mein whenever 2 marks question they are going to ask, they will never only ask magnitude. Whenever they are asking only magnitude, that is very very simple. Torque is equal to R I omega omega p. That's it. Put the values. Even a computer science person, if I just tell him the formula a night before the examination, he will score that 1 mark. The main thing is with finding out the direction. How to find out the direction? Do one thing. Take omega vector and rotate that omega vector. This omega vector, rotate it opposite to omega p by 90 degree. Rotate omega vector by 90 degree in opposite sense of omega p. Opposite to omega p. Opposite to omega p means omega p, whether it is clockwise, so you have to rotate anti-clockwise. If it was anti-clockwise, so you have to rotate clockwise. How do we do this? Sir, like in this case, about y-axis omega p you can see. कैसा है sir? About y-axis omega p is clockwise direction में. So I have to do one thing. I have to rotate this omega vector about y-axis, but opposite anti-clockwise direction में. So if we will rotate this x-axis को about the y-axis, if it is, omega p is clockwise, so you have to rotate anti-clockwise में. And whenever you have to rotate any vector, so you always rotate that vector about its tail. This is the tail, and once you will rotate about the y-axis, so you will reach along this z-axis only. Obvious बात है. So you will reach somewhere along this z-axis. Z-axis is this. So you will reach ultimately here. I don't know which exact size, sir. After rotating this omega vector, this is the omega vector. Rotate करो maybe 90-degree rotation will land you here, or maybe you will land here. You will be along this z direction, but inside the board or outside the board, I don't know. Sir, this is clockwise, anti-clockwise. If anti-clockwise you want to rotate, where will you reach? Anti-clockwise का मतलब होता है, sir, this is clockwise rotation. Anti-clockwise rotation is this. This is your anti-clockwise rotation. Anti-clockwise rotation. And once you have rotated this anti-clockwise, you are here. So this is your direction of the reactive torque, and its effect will be seen. Acha, if torque is acting inside the board, z direction में, negative z direction में this torque is acting, what are the effects? Sir, torque का couple का effect is to rotate, or at least try to rotate. How do we talk? Sir, suppose, let me take the same diagram. Ultimately, we have got that z direction inside minus z direction we are having the torque. If minus z direction we are having the torque, this is the rotor, and suppose this rotor is mounted on some shaft. Careful, careful, careful. Torque is acting inside the board. So clockwise, anti-clockwise, in that sense, if I want to talk, how will you say? Sir, inside the board we are having minus z direction we are having torque. So from the front you can say, sir, it is like this. This is the torque. By right hand thumb rule, this torque which is from the front, it looks like clockwise. This only is inside the board. So torque is actually this. Now what is the effect of this torque? This torque is trying to rotate this rotor. Rotor is mounted on this shaft, so it is trying to rotate this shaft. If first case, if we are having, if this rotor is this shaft is completely free, this end also, this end also, so what you will witness? You will witness that this end starts going down, this end starts going up. So this side end goes down, this side end goes up. What is the effect? This is the effect. If, sir, one end is hinged, this side I have one pin joint, so this end cannot move anywhere. Now what happens? Same torque if it is acting, so this end is not free to move, only this end. So this end will move in the downward direction. If this end is pinned, so the same torque, this end cannot move anywhere, so this end starts lifting up. Or if I am saying that none of these end is free, both the ends I have connected with the help of pin joint, or I have some bearings, I have these bearings, both these ends pe I have bearings, so neither this end can go down nor this end can go up. What will happen? So at least this torque will try to rotate. Its tendency is to provide the rotation, but these supports are not allowing this. That means some reactions will be developed. Reactions will be developed, and because of some torque T, if this is length L of the shaft, so reactions will be plus minus torque whatever we have divided by length L. This is how we write. And how these torques I am going to show? How these torques I am going to show? Sir, we generally represent reaction R1, and this is my reaction R2. Both upward direction I have shown. So just stand here. This is clockwise direction mein. This reaction is also producing clockwise effect. So opposite direction mein same effect. So this is going to be opposite. Opposite matlab this will be negative. So here we are going to have minus ka T by L reaction, and here we are going to have plus ka T by L reaction. What does it? Plus minus shows, plus shows whatever direction we have shown. This is correct. This is upward direction you have represented, but this is negative. It means actually it should have been in downward direction. So ultimately these reactions are producing a torque, opposite torque to this, so that rotation can be avoided. tell me in the chats if everyone is comfortable. बताइए बताइए बताइए. That's how we talk. This is how we can find out what is the effect. Now, they can ask question, sir, I have a ship. Sometimes I have a ship, and imagine kariye, if I have a ship, this plane is moving in a straight path. Sir, plane mein where we are going to have rotors? Plane mein rotors are here. Engine, some parts are rotating. So let me draw some axis first of all. This is your x-axis, y-axis, and this is your, I'm saying, this is your z-axis. Very, very careful. This is x-axis, y-axis, this is your z-axis. Where are the rotors? Sir, rotors are actually here. Whose axis of spin is about x-axis? To make things simple, let me just show you that I have, suppose I have only one rotor which is here. Some planes we have where rotor is at this end. And suppose if this rotor, whose moment of inertia is given as I, it is rotating in from the front, when I am saying it is rotating in anti-clockwise direction. So its omega vector I can show like this. This is my omega vector. This is my omega vector, beta. Axis of spin. If, imagine kariye, this plane is there, its omega vector, this pen is representing the vector, and if this plane is moving towards a straight line towards you, so omega vector ka direction is not changing, axis of spin is not changing. But if this same plane starts taking turn, if it starts taking turn towards left, so can you feel the axis of spin has started moving? Can you feel? It is not taking turn like this. It is going, and on a circular path it will move. But can you feel this axis is tilting? It is taking turn. When this plane is taking turn, so whatever circular path it is moving, that circular path from the top you can see, and that whatever I am seeing from the top, I am showing you this here. So what is happening? You are having a curved path where this plane is moving. Let me show you the plane. Sir, plane, how does it look? Sir, this is the plane. This is the plane, and its omega vector is in this direction. This is the omega vector. And when it is taking left turn, how does it look? Sir, left turn means like this. This is your left turn. Whatever I am showing you in this circle is actually here on this horizontal plane. After some time, when this plane has taken its complete turn, so what will happen? This plane will be somewhere here, and now its omega vector is looking in this direction. This is your omega vector. So how many of you can feel this? That, sir, earlier we were here, now we have turned by this amount, 90 degrees I have turned. About this vertical axis, this is the vertical axis about which we are taking turn. With what velocity? With some omega p velocity. So my axis of spin is taking turn with some omega p velocity. And can you find this omega p velocity? Sir, if you can tell me with what velocity my plane is moving. My plane is moving with v velocity. Its speed is v, and r radius is the radius of the path. So can I write simply omega p, precession speed? It will be v by r. How much is this omega p? Can I find out? Omega p is v by r. Moment of inertia of this rotor is given. So how much torque, active torque, and same magnitude reactive torque, how much it will be? I omega omega p. Omega will be given, that with what speed it is rotating, what is the velocity of the plane, and what radius ka path mein we are taking turn. Everything is given. Just put the values and you will get the answers. The major problem starts when we have to find out what is the effect. How do we find out the effect? Let me tell you that. Careful. Sir, if we are taking left turn, sir, this plane is moving and if it is taking left turn, so from the top, its omega p is how? Pure game of imagination. If we are taking left turn, so top say we are moving anti-clockwise. So top say we are moving anti-clockwise. Anti-clockwise looks like this. This is anti-clockwise. Anti-clockwise from top. For left turn, we are taking left turn. So this omega p, if this omega p is anti-clockwise, so I have to rotate this omega vector opposite to this anti-clockwise, yani clockwise I have to rotate. And once you will rotate clockwise, so where will you reach? You will reach about y-axis, you will rotate x-axis. So you will reach towards z-axis. And z-axis ka matlab somewhere here. How? This is my omega vector. If this omega vector go about its tail, you have to rotate. So if clockwise you will rotate, clockwise is this. Sir, let me write. If you want to rotate this clockwise, so this is my clockwise rotation. If you rotate this in this direction, this is your anti-clockwise rotation. How do we want to rotate this? Anti-clockwise is the omega p, so I have to rotate clockwise. So clockwise, once you will rotate, where will we reach? This is omega vector and I will reach here. Very, very careful. Sir, this is omega. Where? Z direction, negative Z direction. From front, negative Z direction mein we are having. And right hand thumb rule says vector is in minus Z direction. So from front, what will be clockwise, anti-clockwise sense of the torque? Sir, from the front, it will be clockwise direction. Clockwise direction ka matlab ho gaya from the front. If you'll see, so Z direction ke about, we are going to have torque like this, clockwise torque. Now I have shown you the reactive torque. This is your torque beta. Now tell me, because of this torque, rotor or on the shaft of the rotor is this. This is the rotor ka shaft. On the shaft, which is completely free, this end is also free, this end is also free to move. What will be the effect, sir? Because of this torque from the front, it is clockwise direction mein. So nose will go up, tail will go down. So what is the effect? Can I write? What is the effect? Nose go up or lift. Tail, on the other hand, goes down. So this is going to be your effect. Examination mein, whenever they are asking 2 marks question, they will ask, tell me what is the magnitude and what is the direction. How many of you now can answer this? Cam and follower and governor, both these chapters, very small chapters from the gate perspective. Tomorrow both the chapters we will cover. Today it is only about gyroscopic couple. Sir, will you teach about helicopter also? Helicopter, try to think. I have given you one concept that if we are having aeroplane, we are having rotor in this direction, about while taking turn we are moving, about y-axis clockwise or anti-clockwise. So z direction ke about we are going to have our torque, gyroscopic torque. Its effect, how do we calculate, how do we find the direction? I have told you everything. बताइए बताइए बताइए. Tell me, everyone, if till this point you are comfortable or not. Clear है बेटा? चलो, don't try to remember anything, don't try to memorize anything, because if you'll some people think that okay, so if aeroplane turns left, so nose, you have told nose will lift. Are bhaiya, examiner, what will he do? He will simply change the direction of the rotor. My rotor is not rotating like this, rotor is rotating in opposite direction. Everything changes, everything changes. So don't try to memorize anything. And let me write here how my rotor was rotating. From front, rotor was rotating in anti-clockwise direction. So this rotor is anti-clockwise from front side. Front side, say if I'm looking, so this omega vector is looking anti-clockwise. Examiner, if it says I have a rotor which rotates in clockwise direction from front, as seen from the front, everything changes. Clear है ये बात? ठीक है, चलो. So similarly, we can also talk about ships also. Same logic, say we can also discuss ships, but the only thing which is new for the ship is that ship may sometimes they use marine engineering के some terminologies which we mechanical engineers are not comfortable. ठीक है? So we have this big ship, and let me talk about, this is my x-axis, this is my y-axis, and this is my z-axis beta. This is my x-axis, y-axis, and this is my z-axis. First of all, shipping industry ke what are the terms? They don't use these terms that nose goes up or down. No. Tail, they don't call it tail, they call it this front portion, this portion is called as bow, or also called as fore. This back side portion of this ship is called as aft. It is called as aft, or some people also call it as stern. So this is bow and this is aft. Left, right, ship is taking left turn or right turn, they never say left, right. Yes sir, this is left side, this is right side, but they don't use these words left, right. They say left as port side, and this right side ko they say as starboard side. So these terms everybody must be comfortable with. Why I am saying this? Because sir, plane mein I know every concept, but plane mein once they have said that plane is taking left turn, plane is taking right turn, so I can find out what is the omega p ka sense. But examiner, if they have said my ship is there, ship is taking a turn towards the port, I don't know what is the port side, or ship is taking turn towards the starboard side, I am not aware what is the starboard side, so you will not be able to solve this question. So then these terms become, you must be knowing these terms. Acha sir, where is the rotor here? Ship mein I don't see any rotor. Ship mein we have a propeller. Inside this water we have a propeller. Propeller looks something like this. This is the propeller. Acha, don't think that this is a very small size propeller, sir. What does it do? No. This is looking small to you, but this is actually a big, very big. For this ship which I have shown here, a very big size cruise ship or a cargo ship, the propeller ka size is of this order. Massive propeller. Tons is the mass of this propeller. Full adult human, as for the comparison sake, can you imagine? This is full adult 6 feet human, and as compared to this is the size of the propeller. So this massive, huge moment of inertia wala propeller is rotating. When it rotates, sir, what is the axis of spin? Sir, it rotates maybe clockwise or anti-clockwise. So x axis is the axis of spin. Can I say this? This is my x is your axis of spin. Now, if this axis of spin rotates about y-axis, when this will rotate about y-axis, or while taking turn? While taking turn, it is taking left turn, right turn. So it will rotate about y-axis, and y-axis ke about rotation, I will provide either left turn or I will provide right turn. We call it as steering motion. So about y-axis, whatever this omegas we are providing, it is because of the steering. Who is deciding this? Who is providing this? Sir, the captain is there. He decides we have to take a turn. Sir, sometimes, if we are having steering, so about z-axis, I will be having my torque, clockwise or anti-clockwise. You can check that. And because of this clockwise, anti-clockwise torque, what is the effect? Sir, nose wala portion either lifts or it lowers. We can calculate that. Or sometimes in this ship, because of the waves, sir, from the front some waves are coming, so this ship is moving, and because of the rough weather condition, waves have hit this, so my ship can have this motion also. Who is providing this? Sir, I am not providing this. This is because of the rough weather. We call this motion as pitching motion. Pitching motion is about this axis. This is called as pitching motion. So if my axis of spin, which is x-axis, about this axis, z-axis ke about, it is doing pitching motion. So x-axis, axis of spin is rotating about z-axis. So in this case, torque will be developed about y-axis, maybe clockwise or anti-clockwise. And clockwise, anti-clockwise torque, sir, from the top, clockwise or anti-clockwise torque, what does it do? This clockwise or anti-clockwise torque, nose wala portion, either it will be thrown like this or it will be thrown like this, towards left or right. What are the effects? I hope everybody is clear about this. And sometimes shipping industry may we have about x-axis also ship can have motion. Why? Because of the, again, rough weather condition, ship is moving like this, and sideways if waves are hitting, so ship moves like this. We call this motion as rolling motion. This is rolling motion. Do you think because of the rolling motion, are we going to feel any kind of gyroscopic couple? Sir, no, there will be no gyroscopic couple. Why? Because omega vector must change. We are having a ship which is moving towards you. Omega vector is, this pen is representing the omega vector, and if rolling happens, so because of the rolling, our ship is moving like this. So does this omega vector direction is changing? No, sir, it is not changing at all. So rolling doesn't have any effect, any gyroscopic couple wala effect. Is this clear to everyone or not? So this very small, simple sa topic, gyroscopic couple, examination mein they will ask about magnitude of the torque and direction of the torque, and what are the effects of this. How do we solve this? I hope this is clear to everyone. Okay, chalo. So that's all for gyroscopic couple. Very small topic, gyroscopic couple. Tomorrow when we will meet, we will be talking about cam and follower. Again, a very small topic. Gate ke point of view, that is very, very small. Engineering services mein subjective questions if you are solving, so then gyroscopic, then cam and follower becomes very, very important. Governor becomes very, very important. Okay, do solve some questions of gyroscopic couple. You will see that not a very huge varieties they haven't asked. They have asked very, very simple questions. The only major game is about the direction. The person who is comfortable with the direction, you can score very well. Okay, we will stop here. Do promise that all the PYQs of gyroscopic couple you are going to solve. Tomorrow we will meet for our last session, and 8 PM I will start. Sharp 8 PM I will start. Cam and follower, all gate ke point of view se whatever important things are there, I will discuss those, and then I will also talk about governor. Governor mein what questions can be asked in gate examination. Okay, so see you tomorrow sharp at 8 PM. Till the time, thank you, bacho. Goodbye. Love you all, Meri Jaan.